Welcome to Found in Space, a science podcast for kids and teens. Our question today is, can Neptune get hot? And what a wonderful question this is, because this really gives us the opportunity to explore what Neptune is. In order to answer the question, can Neptune get hot? We need to understand a little bit more about Neptune. Now let's start by saying Neptune is one of the most mysterious planets in our solar system. It's one that we don't really know a lot about, and our understanding has been changing over time, but it's a very difficult planet to study. So Neptune is far out in the solar system. It's quite far away from the sun. So when we talk about where things are in the solar system, we talk about how far away they are from the sun. Now, everything in the solar system is orbiting around the sun. Earth is orbiting around the sun, and we are at a distance. Our orbit, it's not a perfect circle, but it's pretty close to being a circle. Our orbit is what we call 1 astronomical unit, or AU, away. And that's about 93 million miles or 150 million kilometers away. So when we want to know how far away something else is, we compare it to Earth's distance from the sun. So for example, Jupiter is about 5 times as far away. Its orbit going around the sun is 5 times as far away as Earth's orbit is from the sun. So we say that Jupiter orbits at 5 astronomical units, or 5 AU, roughly. So sometimes it's a little closer, sometimes it's a little bit farther away, and we're just going to round to the nearest whole number. So Neptune orbits at 30 AU. So 30 times as far away from the sun as we are. So it's out in a very cold part of the solar system. It's really far away from the sun. And it's a planet that we didn't know about until telescopes were invented quite recently, because Neptune is not visible to the human eye. So with the human eye, we can see Mercury, we can see Venus, we can see the moon, Mars, Jupiter, Saturn, and actually, you can, if it's a very, very dark night, very clear night, and you know where to look, you can see Uranus. And you can actually see Vesta, which is the largest of the asteroids, with the naked eye as well. But Neptune is a little bit too far away for us to be able to see at the size that it is. So we had to wait until we had telescopes to be able to see it. Now, today, we call Neptune an ice giant. When it was first discovered, and for many decades, so decades, 10 years, we called it a gas giant. And in fact, in a lot of textbooks, you'll still see it called a gas giant. Because when we looked at it, we saw that it was very different from Earth. It was a lot more like Jupiter than it was like Earth. And so sometimes you'll also hear it called a Jovian planet. That means it's Jupiter-like. But what we've learned more recently is that the ice giants, Uranus and Neptune, are actually very different from the gas giants, which are Jupiter and Saturn. The names are a little bit confusing, though, because when a space scientist says the word gas and when a space scientist says the word ice, they don't mean the same thing that is normally meant when someone says gas or ice. So you hear gas, you think of anything that's in its vapor state, right? You can take water and you could heat water up on the stove, and then it's going to turn into a gas. And with water, you could take water, and if you make it really, really cold, right? Let's say you put it in the freezer, you take all that energy out of it, that heat out of it, then it's going to turn into a solid block. So it makes us imagine that the gas giants are these big balls of gas, and that the ice giants are these big solid balls. But that's not really the case. So When a space scientist says gas, most of the time what they mean is hydrogen and helium. The two elements, the first elements on the periodic table, they're the lightest elements. In most cases that we encounter them, they will be in the gas state of matter. But it could be in any state of matter, and we'd still call it a gas. Now, the word ice is an interesting one because ice can refer to solid water. But ice can also mean a group of chemicals that includes water, but also includes methane and ammonia and a few other of these volatile compounds. So these compounds that have these really, really low boiling points. So anytime that those chemicals, water, ammonia, methane, those are the big ones to remember that are ice, anytime those are in space, we call them an ice. So ice giants are made mostly or a lot of these chemicals that we call ice. But we don't think that the planet is solid. So Jupiter, Saturn, Uranus, Neptune, we don't think there's anywhere to land on these planets. What we understand about Neptune's structure right now, and what we understand about what it is that it's essentially this big liquid ball. Now, figuring that out is tricky. And that's one of the fun things about science, and especially about the space sciences, is it's like this big mystery novel. It's forensics. We're trying to figure out what these things are made from, how did they form, when we weren't around to watch that process. So our best understanding right now is that the solar system, we think, is about 4.5 billion years old. And all the planets and all the little stuff like comets and asteroids, those all formed from the leftover material that didn't become part of the sun. So if you imagine the sun in the middle and this big swirling disk of material, kind of like a frisbee, or you could almost think of it like a big version of Saturn's rings around the sun. And that is what the planets formed out of. Coming up in a future episode, we're going to get into that in more detail. We'll talk about the formation of planets more. But what the planets formed from would have depended a lot on where they were. And so planets that form close to the sun would have formed from rocks and metal, so like Earth. And the planets that formed farther away could have formed from these lighter materials like hydrogen and helium and water and methane and things like that. So we think that Neptune has a lot of hydrogen and helium in it, and it may have a very dense core where it's got some of the stuff that Earth does too. You can imagine it like this really packed, dense ball of mud almost, surrounded by this layer of water. But this layer of water and methane and these other ices, we think is actually hot. So this is getting back to the question, can Neptune get hot? Well, on the outside, it's probably really cold because it's 30 times as far away from the sun as Earth. It's not a lot of light getting out there, not a lot of heat coming from the sun out there. So the surface is probably very, very cold. But as you go deeper and deeper into the planet, we think it gets hotter and hotter and hotter. Now, here's something you can do to help understand why this is the case. If your hands are free, right? So if you can use your hands right now, go ahead and squeeze them together. So take your hands, squeeze them tight, 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 even tighter, as tight as you can squeeze them. Okay. Now, take your palm and put it against your cheek. Do you feel how your palm heated up? Yeah, it's because of the pressure that you're squeezing with. So the more pressure, the hotter and hotter it's going to get. Now, Neptune is really big. No, not as big as Jupiter, but a lot bigger and a lot more massive than Earth is. So there's a lot of pressure as the gravity crushes down and pulls down all of that material. So the deeper we get, the hotter and hotter it becomes. And some estimates think that it might be as much as about 8,000 degrees hot. that's in Celsius, at the core of Neptune. And that heat, that difference between the center where it's really, really hot and the cold up top is probably what drives these really intense, fast storms and wind that whips around the planet. And the wind can just keep going and going and going because unlike a terrestrial planet, a rocky planet like Earth, there's no land for it to hit into. So that wind can just keep going and going and going and going. Now, figuring all of this out about Neptune, this has been a journey and a continual mystery because, as we said, Neptune's very far away. So it's difficult to study with our telescopes. We can use some of our big telescopes like the Hubble or the James Webb, and we can see it a little bit from some of our ground-based telescopes. Mostly we're going to use the space ones. But we've only ever visited Neptune once with a spacecraft. Many of the other planets like Jupiter or Mars, we've sent lots of different spacecraft there to study it and orbit them, so to go around them and take photos and photos. But we've only ever sent one to Neptune. And that didn't orbit Neptune. It just flew by Neptune, took some photos, and then kept going. And that mission was Voyager 2. And Voyager 2 went by Neptune in 1989. That was a while ago, right? It's been over 30 years since we have sent any mission to Neptune, and that's the only time that we've been close by. Now, we learned a lot from the Voyager 2 mission. The Voyager 2 also went to Uranus as well several years before. Uranus is closer to the sun than Neptune is. And that's one of the reasons that we started to shift from calling the ice giants gas giants and calling them ice giants and seeing that they were something that was really different. So in the future years, hopefully we will continue to build bigger, better telescopes that can study Neptune more. And maybe we'll even get a mission to go back to Neptune because there's a lot to learn about it. So coming back to our question, can Neptune get hot? Well, the interior of Neptune probably is really, really hot. But the outside of it is next to space, far away from the sun. So that'll probably stay pretty cold while the inside is hot. All right, this was a really fun one, getting to talk about Neptune and a little bit about what we do know about Neptune and knowing that there's a lot that we don't know. So thank you so much. I hope that you all have dark skies, that you stay curious, and I can't wait to talk more about space with you next time.